Hello, welcome to Unit 6, Lesson 7, Reasoning about Solving Equations, Part 1. The learning objectives for today are to be able to explain how a balanced hanger and an equation represent the same situation, to find an unknown weight on a hanger diagram and solve an equation that represents the diagram, and to write an equation that describes the weight on a balanced hanger. Let's take a look at this picture that shows a hanger with two pairs of socks. Think about some things that you may notice and some things that you may wonder. So some things that you may notice is that there are two pink socks and two blue socks. You may also notice the socks are clipped to either ends of two clothes hangers, and the hangers are hanging from a rod. And you may also notice that the hanger holding the pink socks is level, whereas the hanger holding the blue socks is not level. Some things you may wonder is, why is the hanger holding the blue socks not level? Is something inside one of the blue socks to make it heavier than the other sock? And what does this picture have to do with math? Looking at the two pictures, the hanger on the left, the one with the pink socks, we would describe as balanced, whereas the one with the blue socks we would describe as unbalanced. The left is balanced because the two pink socks have an equal weight, and the one on the right, the blue socks, is unbalanced because one blue sock is heavier than the others. In this lesson, we're going to take a look at a diagram that is a lot like this photo of socks, except with abstract shapes. And you're going to be reasoning about the weights of these shapes. Now I want you to take a look at the first activity. In this activity, you can see there are two different hangers, a lot like the hangers that we just saw with the socks. Now, in the situation, we say all the triangles weigh the same and all the squares weigh the same. For each diagram, you must come up with one thing that must be true, one thing that could be true, and one thing that cannot possibly be true. So go ahead, pause the video, and answer those three questions. So here are some possible responses for one thing that must be true about each diagram. So what I'm going to do is I'm just going to draw a line straight down there, divide it in half. So one thing that must be true in the first diagram is the triangle must be heavier than the square. In the other diagram, we can see that one triangle weighs the same as three squares and a circle. For question 2, it says, what is one thing that could be true for each diagram? So looking at the first diagram, something that could be true, and this actually could apply to both diagrams, is we could say that the triangle weighs 32 ounces. The square could possibly weigh 10 ounces. And then we could even go as far to say that the circle weighs 2 ounces. Now, your answers are probably not the same as mine, but something similar is fine. Now, I know this works out because remember in the first diagram, we want the triangle to be bigger than the square, so 32 is greater than 10. But in the second diagram, we need 3 squares and a circle to add up to the triangle. So if we have 3 squares, 10 times 3 is 30. And if we add the circle, 30 plus 2 is 32. We can now see if the triangle is 32, then the other side is 32 as well. One thing that possibly cannot be true, and this actually could go for both of them, not just one of them, we could possibly say that the triangle and the square do not weigh the same. Okay, it's not possible. We can tell from the first diagram that the triangle has to weigh more than the square. So key things to remember is that when you have a balanced hanger, that means we're saying that each side is equal to the other side. So in our second hanger, this side has to be equal to this. So they must be equal. If it is unbalanced, then they are not equal to each other. They're not equal. So just keep that in mind as we move through this lesson today. Let's go on to lesson 2. All right, let's take a look at this activity. Now in this activity, you have 4 different hangers and notice that they're all balanced. So that tells us each side is balanced to the other side. Notice that we have the same letters in each diagram. So for example, in diagram A, we have 3 W's, in diagram B, we have 2 Z's, and so on. So what we know about those letters is that they all have the same weight. Anytime you see a 1, just note that that means the weight is 1 unit. So for example, over here, we have 1, 2, 3, 4, 5, 6, 7 ones. So all together, that weighs 7 units. So for this activity, you're going to first match each hanger to an equation and then complete the equation by writing X, Y, Z, or W in the empty box. And then you're going to find the solution to each equation. Make sure you use the hanger to explain what the solution means. So go ahead, pause the video, and work on those 2 questions. Alrighty, let's take a look. So the first thing I need to do is match each of my equations to the diagrams. So I'm going to go through and count up the sides that I do know. So for example, I do know that this has 7. So that must match with the very last equation. So hanger A is going to say the equation 7 equals, and I'm going to use 3W because that's what the hanger uses, so 3W plus 1. For hanger B, on the right side, I have 5 ones, so the one that matches with is the first equation. This time, I'm going to use the letter Z because there are Z's there. So 2Z plus 3 equals 7. For C, I have 3 on the right side, so that will match with the second equation. So I'm going to use X, 3X plus 2 equals 3. And then for D, that would be the third equation, which is 6 equals 2y plus 3. Now let's take a look at solving. Now the way I'm going to solve is I am going to use the hangers to show different moves. So let's start with equation A. So when we're solving equations, the idea is that we're taking these equations and we are basically removing things from each side until you're just left with variables on one side and numbers on the other side. So for example, for hanger A, I notice I have an extra 1 here, and I can remove that from the right side. But if I just remove the 1, the left side becomes heavier, and now it's no longer balanced. So I also have to remove a 1 from the left side. Now I have 6 here, along with 3 W's, but I need to know what 1 W is. So all I do is 6 divided by 3, which is 2. So in this case, for hanger A, W equals 2. And basically I know this because one circle weighs the same as 2 squares. Right, if you look here, I would have to divide 2, 2, and 2. All right, let's look at B. Now B, again, remember we're trying to get those variables alone, so we need to get the triangles alone. So this time I have 3 that I need to get rid of. But if I only get rid of 3 there, the hanger is no longer balanced and it's tipping to the right. So I'm also going to get rid of 3 here. So now I see I have 2 1s, so that's a total of 2, and 2 z's. So therefore, if I were to split 2 up into 2, that's just 2 divided by 2, which equals 1. So 1 triangle is equal to 1 square. All right, let's take a look at hanger C. So I need to remove 2 on the left to keep it balanced. I also have to remove 2 on the right. And now I only have 1 left, but my pentagons, I have 3 of those. So I need to split this 1 up 3 ways. So think about if I were to take this rectangle and split it into 3 parts, how much would each part be? So in other words, what is 1 divided by 3? Now, if you try to do this on your calculator, you may have gotten a repeating decimal. Just remember, we don't really care for repeating decimals. Let's try to leave them as fractions. So we're going to leave this as 1/3. So for triangle, or for diagram C, W equals 1/3 because 3 pentagons weighs the same as 1 square. All right, last one. So this time I need to get rid of some on the right. So I have 3 1s I need to get rid of. So I'm going to get rid of these 3. I'm left with 3 over here, but I need to split these 3 among 2. So I'm going to do 3 divided by 2, which is 1.5, or you could leave it as a fraction as 3 over 2. So in this case, for D, y equals 1.5 because 2 crowns weigh the same as 3 squares. So just remember, for each of these, when we were dealing with the hanger, our ultimate goal was to get the variables alone on the side that they're on, which often required us to remove something from that side. But you can't just remove that amount from one side because then your hanger becomes unbalanced. So you have to remove it from the other side as well. From there, you then have to divide what's left by how many of the letters that you had. So for example, in A, we had 6 left, but we need to divide those amongst 3 W's. In B, we had 2 left, and we divided those 2 amongst 2 Z's. For C, we had 1 left, and we had to divide that 1 into 3 groups. And then for D, we had 3 left, and we had to divide that into 2 groups. All right, let's move on to the next activity. All right, so in this activity, you once again have 4 hangers. Notice that each hanger is still balanced. And this time, instead of just using a bunch of 1s, we now have bigger bars to represent different sizes. So for example, in A, we have a big rectangle to represent 7. In B, we have a square that's 10 and a rectangle that's 31. And then we also get into decimals and fractions. We still have our unknown weights. So we have X, Y, Z, and W, and we're not sure what those are. We just know that whatever they are, it'll keep the hangers balanced. For this activity, you are first going to write an equation for each hanger. Then you're going to explain in words how to figure out the weight of the unknown, so the weight of the shape that has a letter in it. And then you're going to explain how to figure out the weight labeled by a letter by reasoning about the equation. So 2, you're reasoning about the diagram. 3, you're reasoning about the equation. Go ahead, pause the video, and complete those 3 questions. All right, let's start with the equations. So for hanger A, I'm just going to write the equations under the hanger. So on the left side of the hanger, I have a 7. Then I have the middle of the hanger, so I'm going to put my equal sign. On the right side of the hanger, I have a 3x, and I also have a 1, so I'm going to do plus 1. So my equation is 7 equals 3x plus 1. For B, on the left side, I have 2 y's and a 10. My equal sign is for the middle of the hanger. On the right side, I have a 31. For C, left side is a 6.8 equals, and I have 2 z's plus 2.2. Last but not least, I have 4w plus 3 over 2 equals 17 over 2. So how would we use the diagram to figure out the weight of the shape labeled by a letter, so labeled by a variable? So in general, I'm just going to make this very general instead of specific to each diagram. The first thing you want to do is you want to eliminate any number that is on the same side as the variable. So for example, in hanger A, I have a 1 on the variable, so I know I need to eliminate this 1. I need to get rid of it. But in doing so, the left side now is heavier than the right side because I removed something from the right side. So then my next step is to eliminate the same amount on the other side. So for example, if I eliminated 1 from the right, I also need to eliminate 1 from the left. Now I know that we just have a bar that is 7. So essentially what we're going to do is 7 minus 1, which is 6. So now this bar has a weight of 6. Last, you're going to divide up what is left by how many variables there are. So if we look here, I have 3 variables. So this tells me I need to divide 6 into 3 groups. So we're going to do 6 divided by 3, which in this case is 2. So that's a general statement for using the hangers to figure out what the unknown is. Now let's talk about what we would do to equations to figure out the unknown. So for this one, we're going to actually do all 4 hangers. So let's start with hanger A. And our equation was 7 equals 3x plus 1. And if we recall from the hanger, the first thing we did was eliminate a 1 from the side with the x's are. So I'm going to do the same thing here. I'm going to eliminate 1. So in order to eliminate that, I need to subtract. But we also eliminated 1 from the other side, so I'm going to subtract 1 on this side as well. When I do that, 7 minus 1 is 6. And when I do the minus 1 on the other side, I'm just left with the 3x. The next thing we did was we divided up our variables into groups. And because there were 3 variables, we have to divide them into 3 groups. So you need to divide both sides by 3. Now, here's the thing. A lot of us may just want to do 6 divided by 3, but ultimately our goal is to make sure we're using balanced moves to solve these. So if I have to divide the 6 by 3, I need to also divide the other side by 3, because our end game is to make it so we have one single x left. So if you split 3 x's into 3 groups, you're left with 1 x in each group. And then the same thing on the other side, if you split 6 into 3 groups, you're left with 2's in each group. So therefore, we know x is equal to 2. Let's look at B. For B, our equation was 10 plus 2y is equal to 31. So if we look back at the hanger, remember our first step would be to eliminate the 10 so that we get the variables alone. So that's subtracting 10. But I also have to subtract 10 from 31 as well, because otherwise our hanger is not balanced. I'm left with 2y equals 21. And then the next step would be to take my y's, and because there's 2 of them, I need to divide them into 2 groups. And then the same thing for the 21, I need to divide those into 2 groups as well. So I show that by dividing by 2 on both sides. If I have 2 y's split into 2 groups, that's 1 y. And then 21 split into 2 groups, that's 10.5. So we are saying the weight of y is 10.5. Okay, let's do C. So the equation for C was 6.8 equals 2.2 plus 2z. So I need to eliminate the 2.2 first. So minus 2.2, but I have to do it on the other side as well, otherwise my hanger is not balanced. 6.8 minus 2.2 is 4.6. I'm left with 2 z's. Now because I have 2 z's, I need to split them into 2 groups. So I'm going to divide by 2. I'm also going to divide the 4.6 by 2. So 4.6 divided by 2 is 2.3. And then if I split 2 z's into 2 groups, that's 1 z in each group. So therefore, z is equal to 2.3. Last, we have hanger D. So hanger D, the equation was 17 over 2 is equal to 4w plus 3 over 2. I first need to eliminate the 3 over 2, so I'm going to subtract that. But I have to eliminate it from both sides. 17 over 2 minus 3 over 2 is equal to 14 over 2. And 14 divided by 2 is just 7. So I'm not going to even write 14 over 2. I'm just going to write 7. So I have 7 equals 4w. So I need to split the 4w's into 4 groups since there's 4 of them. And I also need to split 7 into 4 groups. So when I divide both sides by 4, on the left, 7 divided by 4 is 1.75. And then when I do 4w's into 4 groups, there's 1w in each group. So therefore, w is equal to 1.75. So if you need to have all of these steps written the same way that I have written them, I need to see these balanced moves. This is what you should show your work going forward. And we'll keep practicing this. So if it's not perfect, that's okay. We'll keep working on it. But for the notes today, I need to see these balance moves. So the key thing to remember here, you may notice that these equations all have something in common. It's always some number, and the number differs, right? So we'll say P times a variable, and the variable is different, but we'll just use X, plus another number. It's different every time, but we'll call that Q. And then it's equal to a third number, again, different every time. We'll call that R. They all have the same structure. So when you have equations with this structure, the first thing you're going to do is subtract the same amount from both sides. To isolate variable. And then you're going to divide that variable. Divide, and not just the variable, but both sides, so that you end up with a single variable. Now, prior to this lesson, we were solving equations like this by reasoning, and we talked about how you always have to subtract first and then divide. So it's the same idea. We're just putting more structure to it now. So that's the expectation, is that you are applying the structure to equations that are set up like this. So that's it for today's lesson. Thanks for watching.